So I wanted to create a video that would allow you to review some of the ideas related to chemical nomenclature that we've covered in grade 10 science. So I'm going to start off with our easy compounds, our easier compounds to name, which are the binary compounds. So the prefix bi means two, and so these compounds are only going to contain two different types of atoms in them. They're not very complicated. So we're going to start off with the compounds containing what's called a monovalent metal and a non-metal. And so I'm going to just pull up a browser here. And so here I have a browser with the periodic table of the elements. Let me see if I can zoom in a little bit here. Nope, not letting me zoom in. That's okay. So I want to remind you of a few details. All of the elements in this first row here, when they form ions, will form ions with a positive 1 charge. All of the elements that are in this second column over here will all form ions with a positive 3 charge or positive 2 charge. Whoa. All of the elements over here, if I jump to the other side of the periodic table, all the elements in this column right here will all form ions with a positive 3 charge. So now I know that my inert gases, my noble gases, all have a full outer shell, and so they're going to be very non-reactive. But all of the elements in my halogen group will all have 7 valence electrons. So they're actually wanting another electron, and so what that does is it gives them a negative 1 charge as an ion. So oxygen and all of its counterparts below will all form ions with a negative 2 charge. And then nitrogen and its counterparts will all form ions with a negative 3 charge. So that's important to know. Now another thing that's important to remember is that there's this staircase line. Oops, I'm going to use a different color so that shows up a little bit better. And the staircase line essentially divides my non-metals from my metals. So that's also important to remember. In case you're wondering whether an element that you're not familiar with is a metal or a non-metal, that's one easy way to remind yourself. Now, in terms of a metal being monovalent or multivalent, all of the metals in this group will all be monovalent, having a charge of +1. All of the metals in this category will have a positive 2 charge because only and ever. Now it starts to get a little bit iffy, right? So some of the metals in our transition area will have only one possible charge, and that charge will be indicated. So for example, if you were to look in at, and if you have your periodic table handy, pull out zinc, and you'll see that zinc can only have a positive 2 charge. That makes it monovalent. Whereas its neighbor to the left, copper is what we call multivalent because it can have positive 2 or a positive 1 charge. And this periodic table does not show that. However, yours that we've talked about and used in class will indicate those charges. All right, and so compounds containing a monovalent metal and a non-metal are the easiest ones to name. The metal ion will keep its name, and then the non-metal simply has its ending changed to IDE. So when I look at this compound right here, NaCl, the first thing I notice is that I have sodium, which is a monovalent metal, and then chlorine. So my naming of this compound is very straightforward. It's very simply sodium. So keeping the name of my metal, and then chloride. So notice that it's not chlorine anymore, it's chloride. Next, so now I look at this compound, and some of us may want to say, oh, there's 2 there, so do I call that difluoride? Well, the answer is no, not if you see that you have a compound involving a metal and a non-metal. So in this case, magnesium is also a monovalent metal, and so I'm going to straight up name it magnesium fluoride. And lastly, again, I see lithium and oxygen, and some of you may look at this 2 here and say, well, what about the 2? But remember that that's strictly there because lithium has a positive 1 charge as an ion, and oxygen has a negative 2 charge as an ion. And when I cross those down, this is the formula that I get. However, that is neither here nor there. I'm going to name this lithium. And notice I'm not writing oxygenide, it's simply oxide, and I'm done. So now if I'm looking to find the name or the formula for a compound given its name, then I'm going to use my crossover rule to do that. And remember that if the formula is not in lowest terms, I'm going to reduce it to lowest terms, and that's true of all ionic compounds. So for example, if I had something like A2B2, that would reduce to AB. If I had something like A2B4, then that's like saying I have a ratio of 2 to 4, which of course is the same as 1 to 2. So I would reduce that to A1B2, which would, in chemistry we would usually call that just AB2. So all of those are important to remember. So let's do a little bit of practice here. So here I have calcium chloride, and so I'm going to take a look at what its charges are, and I need my periodic table to do that. So I can see that calcium is in the 2nd row on the periodic table, and that gives it a positive 2 charge. Chloride is on the 2nd from the right column, that gives it a negative 1 charge. So now all I do is I take this charge and I cross it down. I don't care about the positive or the negative, I just care about the value of the charge, and I cross it down. And so what does that give me? That gives me Ca1Cl2. Now typically, if there's a 1 as a subscript, we typically don't include that. You normally won't see it, so we would just keep that out. CaCl2, sort of like in math, how if you have x, you know that it's 1x, but usually we don't write the 1 in. All right, so let's try another example. So sodium phosphide, so that "ide" ending is telling me it's a binary compound. I look to find out the charges. Sodium has a positive 1 charge, and phosphorus has a negative 3 charge. And so now I'm going to do the same thing, crossing down. That's a positive 1, that will go beside phosphorus, and the 3 will go beside my sodium. So that will give me Na3P. And I'm done. Last but not least in the series of examples for this particular set of questions, I'm going to look at magnesium. So magnesium has a 2+ charge as an ion based on where I find it on the periodic table. Oxygen will have a 2- charge. So then I go ahead and I cross those charges down. And when I cross those charges down, I get Mg2O2. But of course, I know that a 2-to-2 ratio is the same as a 1-to-1. So I'm going to take those 2's and reduce them, and that will give me my final formula, which is MgO. So now things are going to get slightly more complicated because I want to teach you the rules for naming compounds that have multivalent metals in them, right? So multivalent, as we've talked about, indicates that the metal has more than one possible charge. So an example, if you have your periodic table close by, you'll be able to see that if you look up, I'm going to say iron, Iron, you know, it can form ions with 2 different possible charges. It can form ions with a 2+, or compounds containing iron 2+, but it can also form ions containing iron 3+, and that makes a really big difference in terms of the chemical that results. The chemical that results will have different physical and chemical properties. So a big part of figuring out how to name them is first being able to identify the charge on the metal ion. And I would say you can either do a reverse cross over method to figure that out, or sometimes I will say to do a test cross. So I find that the test cross tends to be sort of an easier way for people who are struggling with this. So what I'm going to do is I'm going to just zoom in here, and we're going to work on a few examples. So when I look at this compound, as soon as I see that I have a metal that is multivalent, I'm going to do a test cross. So I say, well, iron, as we just saw, can have a 2+ charge, or iron can have a 3+ charge. Well, what happens when I combine it with chloride? So chloride always has a -1 charge. So I'm just going to go ahead and do a crossover with each of these. So iron with a 2, and iron, and then do the same thing with my second compound. Just crossing over my charges. So when I do that, I can see that in my first case, I end up with iron with a FeCl2. And in the second case, I end up with iron FeCl3. So then I go back and I say, well, which of those was the compound that I started with? What does it match? Well, it matches the case where I tested with iron with a 2+ charge. So that tells me that in this compound, I have Fe2+. And that's going to be really useful for me when I'm going ahead and deciding how to name this compound. All right, so let's try a second example. I'm going to move this up a bit. Let's try this compound, and maybe give it a try on your own if you're comfortable. So again, I'm going to take a look at the periodic table, and I notice that copper has 2 possible charges, copper +1, but I also have copper with a 2+ charge. So in each case, I'm going to cross it over with oxygen, and oxygen always has a -2 charge. So I'm going to do my crossover rule with each of these compounds, right? And so I'm noticing that here, crossing down, the formula that I get in this first case is Cu2O. And in the second case, crossing down my charges, I have Cu2O2. And so, well, which of those is my match? I'm going to just take this further and remember to reduce this to lowest terms. When I look at the formula that I am inquiring about, it matches this one right over here. And so that tells me that in this case, it was copper with a +1 charge. Copper with a +1. That was the charge on the copper in this compound. All right, let's try one last example before we move on to the naming system. So the naming system here, we have to know how to indicate the charges. So I see lead oxide, so I'm going to take my lead and recognize that lead has more than one possible charge. So I can have lead with a 2+ charge, and I can have lead with a 4+ charge. So I'm going to cross it over with oxygen with a 2- charge and see what I get. So in this first case, I start with Pb2O2, which of course I'm going to reduce to be PbO. So those 2's will cancel. And Pb4 4+ and O2- will give me Pb2, oops, forgot my little b in there, 2O4. And so this is the same thing as saying I have a 1 to 2 ratio. And so I know that I need to reduce that, and that will give me PbO2. So I go back and say, well, what was the compound I was looking for? PbO2. And that matches this guy, which tells me that the lead 4 is the charge on lead in this compound. All right, so there are two naming systems that I need to make sure you're aware of for managing naming compounds with multivalent metals in them. So the problem that exists is that if I were to just name a compound, say, let's say FeCl2. Well, this is an example where I can't just call it iron chloride, because that doesn't tell the reader, well, is the iron in this compound iron 2+ or iron 3+? If I just say iron chloride, the reader might think that I have iron 2, they might think that I have iron 3. So without any other information, that's kind of ambiguous for the reader. So in one possibility, what you can do is use Roman numerals. So Roman numerals in the name will tell the reader what the charge is on the metal ion. So just let's do a quick review of Roman numerals. So Roman numerals, we have 1, 2, 3, 4, and this little bars on the top and bottom are kind of optional. 5, 6, and that's probably about as far as we'll go this year in this course. So again, I'm going to name these using the stock system, and to speed things up, I already know what the charge is on iron, but we would go through the same process as I just described to identify the charges. So if you need to pause the video to try that out yourself, feel free to go ahead and do that. So I know that in this compound, the iron is iron with a 3+ charge, because there's a little 3 that got crossed down, and that's a good clue for me. And so I'm going to say, all right, well, in this case, then, I can't just call it iron chloride. I'm going to call it iron 3 chloride to indicate to the reader that the iron that's in the compound is iron with a 3+ charge. Now, in the next example, I see that I have copper with a +1 charge. And so in this case, I'm going to call this copper, and then in brackets indicate to the reader that it's copper with a +1 charge, and then oxide. Lastly, I can see in this compound that the lead that I have is lead with a 2+ charge, because, you know, oxygen has a 2 negative charge, and so they would have canceled each other out. And so I go ahead and I name this. I'm not just going to call this lead oxide. I'm going to call it lead 2 oxide to let the reader know that, in fact, I have lead with a +2 charge in this particular compound. So more often than not, what you're going to see is you're going to see that you're given a name, and you're going to be asked to transform that into its chemical formula. And so we're going to apply the crossover rule the same as we have before. So let's give these a try. I'm going to make this a little bigger for us. So I have gold oxide. So I'm going to, the 3 right here, this actually makes it quite simple for me. You know, I need to look for the charge on the periodic table, because they're telling me that in this compound, gold, which has the symbol Au, has a +3 charge. And oxygen always has a -2 charge, as per the periodic table. Then I take these and I cross them down. And then the formula that results is Au2O3, and that's it. So again, this 4 right here is telling me that I have tin, which says the chemical symbol Sn, has a 4+ charge. And so oxygen, again, with a 2 negative charge, I'm going to cross down the 4 and the 2 to the opposite element, and that will give me Sn2O4. However, I know that the 2 to 4 ratio should be reduced to 1 and 2, So the final formula that results is SnO2. Done. So the second method that is used, and you may be saying, well, why do we need to have two methods? Well, likely the classical method was, came out first. And it's great because it allows you to deal with situations where you have only two possible charges on a metal. So the metal that has the lower of the two charges would get the OUS ending, and the metal with the higher of its two possible charges would get the IC ending. So the flaw in that system is that often metals, multivalent metals, will have more than simply two charges. So they probably figured that out and decided on the stock system with the Roman numerals. However, many people in many books will still refer to the naming system that involves using Latin names, so it's important for us to know the naming system. All right, so if I have, so let me start. So for example, I know that in FeCl2, the iron is iron 2+, because I look at this 2 and it got crossed down. So that also helps me, the same method helps me to see that iron will have a 3+ charge in FeCl3. And so if I'm using the Latin names, the Latin name for iron is ferrum, and so I'm going to start out with that, fer, and then fer. Now the lower of my two charges is this iron 2, so it's going to get the OUS ending, so ferrous. And then the higher of my two charges is going to get the ic ending, so iron 3 would be ferric. And then I go on and I name it as I normally would, chloride and chloride. So ferrous chloride and ferric chloride. So before we carry on with this naming system, let's just go through the basic Latin names. So if I have iron, iron would be ferrum. So notice the endings here. Here I have stanic versus stanus, for example. And so we're going to, let me teach you how to use those. Okay, so again, just to keep things moving along, we've already looked at how to identify the charges. So I'm just going to pretend that we went through that exercise. In this first compound, I see that I have iron 3+. Now, I know that iron can have two possible charges. It can be iron 2+ or iron 3+. So this is the higher of the two charges for iron. So that means I'm getting the ic ending. So this would be ferric chloride. In my next example, the copper that I have here is copper 1. Now copper can have a +1 charge or a +2 charge, but in this case the compound has a +1 charge. So that's the lower of the two charges for copper. So that means I'm going to call this cuprous, the OUS ending, cuprous oxide. And then lastly, I have lead, and lead can have two possible charges. There's the 2+ charge, and there's lead with there's lead with the 4+ charge. Now I'm going to tell you that in this particular compound, lead has a 4+ charge. And so I'm going to go ahead and use the IC ending because it has the higher of the two charges. So plum, bic, and then oxide. Done. All right, so let's go ahead and do the reverse, which is to use those Latin names and create some formulas. So when I look at the first example that's provided, I notice that I have the OUS ending, orus, and orus refers to gold. So I know I have gold. So I'm going to look on my periodic table and I'm going to say, well, what are the two charges for gold? Well, gold can have a +1 charge, and gold can have a +3 charge. But since I have the OUS ending, that's what's telling me that in this compound, gold will have the +1 charge. So I'm going to go ahead and put that in gold. So AU, +1. And I'm going to cross that down with sulfide. Sulfide is an ion with a -2 charge. So that results, when I cross that over, AU2S1, which of course I'm not going to put in. Now let's look at our second example. So stannic, okay, so that is tin, and tin with the higher of its two possible charges. So tin can have a 2+ charge, and tin can also have a 4+ charge. Since the IC ending is there, I know that I'm dealing with tin with the 4+ charge. So SN 4+, and then oxygen is O2-. Crossing those down gives me SN2O4, which of course I want to reduce to lowest terms, and that will give me a 1 and a 2. So my final formula is SNO2. Done. So now I'm at the point in the lesson where I'm going to talk about, well, what about those compounds that don't contain a metal and a nonmetal? Those compounds that contain two nonmetals. So those are going to be on the right of the staircase, right? So now we have to be aware of that. We're not going to just simply look at changing the ending to "-ide" or looking to see if the metal is multivalent. We're going to also have to look at the compound and see, well, what types of elements are making that compound up? So in the case where I see carbon, which is a nonmetal, and oxygen, which is a nonmetal, I have to use prefixes. Because these metals, these nonmetals, you know, they are not going to form ions with each other that will attract. They're going to have to share electrons. And so the crossover rule won't really work. It's not an ionic compound. So given that, IUPAC has decided that we're going to use prefixes to identify the number. Good afternoon. So here is a list of the prefixes that we're going to use based on the number of atoms that are actually present in the formula. So I'll have you take a look at the mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And so make sure that you memorize those because you do need to know them. So that provides an explanation for the fact that carbon dioxide has the formula CO2. The di here is telling me that there are 2 oxygens in the formula. Now, it's another little bit that's kind of a bit of a pain, but it's important to know that the prefix mono, which indicates one of an element, is usually omitted, is usually not put in if there is only one of the first atom. So for example, I see in carbon monoxide, which is CO, notice that I left out the mono for carbon. Right? But I did include the mono for my second element, oxygen. Okay, so I wouldn't normally call that monocarbon monoxide. I would simply call it carbon monoxide. But if there happened to be 2 of my carbon, I would still use the di prefix. Let's do a couple of practices here. So xenon tetrafluoride. That is telling me that I have 1 xenon and 4 fluorines. Tetra means 4. Tetraphosphorus, so P4. Decoxide, dec means 10, so O, 10. Lastly, let's do the reverse. I see sulfur is a nonmetal and so is oxygen. So I'm going to call this sulfur. And I have 3 oxygens, so trioxide. Next I have phosphorus and chlorine. Both of them are nonmetals, so I'm going to choose to use prefixes here. Phosphorus, penta for 5, chlorines, pentachloride.